Okay, in this video, we're going to talk about the simple StatDisk assignment number 2. This is similar to the actual StatDisk assignment in my math lab, the second one. And when I'm presenting in this video is how to use StatDisk to answer the questions, which are going to be similar to the ones in the actual StatDisk assignment number 2 in my math lab. We're going to start with problem number 1. The lengths of human pregnancies are normally distributed with a mean of 268 days and a standard deviation of 15 days. What is the probability that a pregnancy lasts at least 300 days? And we're going to round to 4 decimal places. Okay, so I've already identified what's in this particular problem here. We have a mean of 268 days. That's going to be your population mean, because we're looking at a normal distribution with a population mean and a population standard deviation. Here, the standard deviation, of course, is going to be 15. That's sigma, equaling the 15. And of course, we're looking at a probability that a pregnancy lasts at least 300 days. So X is going to be equal to 300. Okay, so now we need to convert X equals 300 to a equivalent Z-score. And here we're going to use this formula, Z is equal to X minus mu, all divided by sigma. All right, now X is 300, we just substitute this X with 300, minus mu, substituted with 268. That's all divided by sigma, which is 15. And then we just simplify. Let's do 300 minus 268. That's going to be 32. And then 32 divided by 15 will be 2.13 with the bar on top of the 3, meaning that the 3 repeats. So it'll be 2.13 repeating. Okay, now in StatDisk, they're going to ask for you to give the Z-score for that. That's all they're going to ask for in this case. All right, so now let's go to StatDisk. And by the way, you should already register for StatDisk. If you haven't, there is a link on in the Canvas learning system where you should see under getting started in the getting started module, you should see StatDisk. Click on that, and then there's a link that you can click on to register for StatDisk. Okay, so now let's do this. We want to go to analysis. That's the first thing we want to do here, and then go to probability distribution. Click on that. Now we're dealing with a normal distribution, so we're going to select normal distribution. And this is the screen you should see. The only thing you're going to see is the Z value and the cumulative area from the left. The only thing we need to enter is a Z value. So we're going to enter 2.1. And since 3 repeats, I'm going to try to put in a bunch of 3 so that way I can get an accurate probability. And then the cumulative area from the left will leave that blank. And then we'll go ahead and click evaluate. And this is going to be the output that you'll see on the right side. Now, the one we want is the one that says, I believe in this case, at least. Well, at least means greater than or equal to. And greater than or equal to means we're looking at the area to the right, not the left, the right, because greater than means bigger, bigger, bigger. We go to the right, it gets bigger and bigger. So it's this one right here that we want, the area to the right. Now we're going to round to 4 decimal places. This will be 0.0165. 0.0165. That represents the probability that a pregnancy lasts at least 300 days. 0.0165. Okay, so that's all of problem number 1. All right, problem number 2 is this. There are 3 parts. Given a population with a normal distribution, a mean of 0 and a standard deviation of 1, find the probability of a value less than 0.4. All right, so our X is going to be that 0.4, so we need to convert that to a Z-score using this formula right here. Z is equal to X minus mu, all divided by sigma. And in this case here, your X is going to be that 0.4 minus mu, in this case, that's the mean of 0, all divided by the standard deviation, sigma of 1. So 0.4 minus 0 will be 0.4. 0.4 divided by 1 will be 0.4. So that's going to be your z-score. That's the number we'll enter in StatDisk under the box that says z-score. So let's go to StatDisk. And in this case here, the z-score, the z-value, 0.4, we type that in. Cumulative area from the left, we leave that blank, so we click evaluate. All right. And it says, in this case, less than. So we want the one that says the cumulative probability on the left. Okay. Cumulative probability on the left. So in this case here, that probability value would be 0.6554. If we was to round it to 4 decimal places, 0.6554. Okay, so that's part A. Now part B, you're given a probability with a normal distribution, a mean of 100 and a standard deviation of 15. You want to find the probability of a value greater than 117. So this time we need to convert 117, which is going to be x, to a z-score. Using this formula, z is equal to x minus mu divided by sigma. Okay, so here your x, that's going to be 117, minus mu, which is your mean, that's 100, all divided by the standard deviation, sigma, which is 15. And then simplify, 117 minus 100, that's 17. 17 divided by 15, if we were to round this off to 2 decimal places, that would be 1.13. So your z is going to be 1.13. And then we're going to enter that value in the box for the z-score. It's still going to be a normal distribution. So let's go back to StatDisk. We're still on a normal distribution. So here your z value will be 1.13. You type that in. And then click on evaluate. We always leave the cumulative area from the left blank. And it does say greater than. Yeah, greater than 117. So we need to look at the one that says the cumulative probability from the right. And that value will be 0.1292 if we were to round it to 4 decimal places. So in this case, the probability of a value greater than 117 will be 0.1294. Okay. And then finally, part C has this. Let's say we're given a population with a normal distribution with a mean of 98.6 and a standard deviation of 0.62. We want to find the probability of a value between 97.0 and 99.0. Okay. Now we got to convert both of these x values, 97.0 and 99.0, to z-scores. So starting with 97.0, we have to use this formula. Z is equal to x minus mu, all divided by sigma. Your x value is 97 minus the mean of 98.6, all divided by the standard deviation sigma of 0.62. Simplify this, you'll get 97 minus 98.6. That's negative 1.6, divided by 0.62. You'll end up with negative 2.58. So the z-score for the value of 97 will be negative 2.58. And then the z-score for 99, we convert that using the z formula. Z is equal to x minus mu, all divided by sigma. Here, x is, in this case, 99, minus your mean, which is mu, minus 98.6, divided by sigma, the standard deviation, 0.62. So here, 99 minus 98.6, that's 0.4. 0.4 divided by 0.62 will be 0.65. So the z-score for 99 would be 0.65. Okay. Now we're going to individually enter these into StatDisk to find out. In this case, we're going to be using the cumulative probability from the left on each one of them. All right, so let's go back to StatDisk. Under Z value, let's start with the negative 2.58. Negative 2.58. Read the cumulative area from the left blank and then click Evaluate. Let's look at the one that's on the left for this one, and we'll do the same for the other one as well. For negative 2.58, the cumulative probability on the left is 0.0049, rounded to 4 decimal places. Okay, so you might want to write that down somewhere. And then for the Z value, 0.65, that's the other one, 0.65, and then click Evaluate. Now let's look at the one from the left. This one would be 0.7422, rounded to 4 decimal places. Okay, so now what I need to do here is subtract those two, because I'm looking for the area that's in between the two, between 99 and 97. Well, between 97 and 99. All right, so I'm going to switch to another screen. Okay. Here we go. All right, this one I'm going to do. I'm going to type in 0.7422, and then I'm going to subtract from it 0.0049. I'm sorry, minus 0.0049, and then hit enter. All right, and this is what I get for an answer, 0.7373. Okay, so here it is again, 0.7422 minus 0.0049. So that's 0.7373. That represents the area in between those two numbers, 97 and 99. So that means here that the probability for a value that's in between those two would be 97.99. Okay. Okay. All right, now let's look at simple problem number 3. Where it says here, from a 3M privacy filters poll in which respondents were asked to identify their favorite seat when they fly, N is equal to 806 and X is equal to 492, who choose the window seat. Construct and interpret a 95% confidence interval estimate of the population proportion P. Okay. All right. I don't know if y'all didn't see sample problem number 3, but here it is right here. So here we're constructing a 95% confidence interval estimate. So we can do that on StatDisk. So let's go to StatDisk. This time we're going to go to analysis, and then we're going to go to confidence intervals. Confidence intervals. Now, the one we want to select, since we're dealing with a proportion, we're going to deal with proportion one sample. Proportion one sample. All right, the confidence level, they give 0.95 as a default confidence level. Now, if they say 90%, then you have to change it to 0.90. Or if it's 99%, you have to change that to 0.99. But we're dealing with a 95% confidence interval estimate. So here, 0.95 would be it. And then the sample size, you were told N was your sample size. That's 806. So we'll type that in and then go down to number of successes. They told you X was 492. And then click evaluate. Now, the one we want to look at is the 95% confidence interval using the normal approximation. That's the one we want. And of course, we're told to round to 3 decimal places. So here in this case, the lower limit is 0.577 and the upper limit will be 0.644. Okay, so now what that means here is this, that we are 95% confident that the proportion of respondents who identify their favorite seat as the window seat falls between these two values, 0.577 and 0.644. That's how we interpret a confidence interval. Okay. All right, next we'll look at this one. This is sample problem number 4. A physician wants to develop criteria for for determining whether a patient's body mass index or BMI is atypical, and she wants to determine whether there are significant differences between males and females. Use the sample BMI from data set 1, which is body measurements male/female on StatDisk. And then we're going to use that and then get our results and then answer the following questions. Construct and interpret a 99% confidence interval estimate of the mean BMI for males. And then part B will construct another 99% confidence interval estimate of the mean BMI, this time for females, and then compare the results. And then ask ourselves, can we conclude that the population mean for males and females are different? And the question would be why or why not? So here we're going to go to StatDisk. Now, this time, we're going to need the data sets. So we need to go to data sets up here. And we're going to go to the one that says Elementary Statistics 12th edition. Okay, keep that in mind. Elementary Statistics 12th edition. That's the one we're going to use here in this case. Click on that. Now you're going to see two things: body measurements for female and body measurements for male. We're going to start with the male, which is going to be 1B, body measurements for male. Click on that because that's part of part A in this case. Okay, so here's our BMI, which is right here. All right, now the problem with that is this: we need summary statistics before we can even attempt to do this problem, because we need to know what our sample size is, and also we're dealing with the mean weight. We need to know what the sample mean is for men. So here's what we're going to do right here. I'm going to go to data up here at the very top. Go to data. And then we're going to go to, and I hope this is correct. Here we go. Explore data dash descriptive statistics. That's the one we want. Click on that. And then we need to select the data from the column. We're doing BMI in this case. Now, whatever they tell you, in the actual StatDisk assignment is the one that you want to select. If they say the post rate, you need to select post rate. If they say weight, you need to select weight. Or LDL, select LDL. But in this example, we're dealing with BMI. So I'm going to select BMI from this drop-down menu and then click Evaluate. Okay, now there are some things I'm going to need here. I need to make the sample size, which is right here. That's 40. I also need the mean, which I'm going to round to one decimal place. That's going to be 26.6. So in this case here, the sample size will be 40. The sample mean is 26.6 if I round to one decimal place. I also need something else, the standard deviation. That's this number right here. To two decimal places, that'd be about 5.36. Those are the three pieces of information I'm going to need here in this case. All right. Because I'm going to need the summary statistics in order to get my, to enter what I need. So when I go to analysis here, I need to click on analysis, then go to confidence intervals. This time I'm going to be selecting mean one sample because the one sample was the min. All right. Because as you can see, I need the sample size, the mean, and the standard deviation. Now, in that problem, the confidence level we're dealing with is, and I'm going to go back to this, says 99%, and it's going to be for both. 99%, they give us a default of 0.95. We need to change that to 0.99. And then under sample size, it was 40, so N will be 40. And then the sample mean was 26.6 approximately. And then the sample standard deviation was approximately 5.36. So we type in those values in. We leave the population standard deviation blank because of the fact the population standard deviation is never known in reality. And then we click Evaluate. And this is our 99% confidence interval. Okay. And that would be, let's see, 24.3 to 28.8. Now they might say two decimal places, so it'll be 24.31 to 28.89. So to interpret that, we can say that we are 99% confident that the true mean BMI for males would be would fall between 24.31 and 24.89. All right, now we got to do the same thing for females. So I'm going to go back to data sets, choose the one that says Elementary Statistics 12th edition for this one. And and I think you're going to have to do the same thing for the actual StatDisk assignment, Elementary Statistics 12th edition. Now we're going to select body measurements for females. So it's going to be this one right here. And we're going to do the BMI as well. So here's the column for BMI. All right, so now let's go to data because we need the mean, the sample size, and the standard deviation. So let's select data and then explore data, descriptive statistics. Click on that. Now the column that we want to select is going to be BMI for females. So go to BMI and then evaluate. So here, this is the data for females. The sample size is 40. The mean is 24.4 approximately. And also, I need the standard deviation. If you look at it, the standard deviation would be approximately 7.39. Okay, so now let's use that to do our analysis or construct the confidence interval. So let's go to analysis first, and then go to confidence intervals. Click on that. And then we're dealing with a mean one sample. Now, the confidence level is still 99%, just like the other example. So we'll change this to 0.99 as I have done here. The sample size n, that's going to be 40. Go down to the sample mean, that's going to be 24.4. And then the sample standard deviation was approximately 7.39. We always leave the population standard deviation box blank. Then click evaluate. And here is your confidence interval right here. From 21.24, if I was to round this off to 2 decimal places, 21.24 to 27.56. And what that means here is that we are 99% confident that the true mean body mass index for all females fall between 21.24 and 27.56. Okay. And then for part C in that problem, and I'm going to go back to that PowerPoint slide, where you were to compare the preceding results, and can we conclude that the population mean for males and females are different? Why or why not? Okay. They're not different because in this case, there is an overlap between the confidence intervals here. Because for males, it starts at 24.31, ends at 28.9. For females, it was 21.24, but ends at 27.6. So somewhere there is an overlap in those two. So we can say that the population for males and females are not different. All right, and finally, sample problem number 5. A manufacturer of golf equipment. As a manufacturer of golf equipment, the Spalding Corporation wants to estimate the proportion of golfers who are left-handed. How many golfers must be surveyed if we want 95% confidence that the sample proportion has a margin of error of 2 percentage points? So we got 95% confidence and 2 percentage points. Now we can find the sample size determination through StatDisk as well. So let's go back to StatDisk. Now we're going to go to analysis. Underneath that, you're going to see something called sample size determination. Click on that. Okay, now we're dealing with a proportion, by the way, so we need to select the one that says estimate proportion. All right, confidence level, you're given 95% as a default or 0.95. But if it was 90, you'll have to say type in 0.90, or 99%, it'll be 0.99. All right, now the margin of error was 2 percentage points, but 2% as a decimal will have to be 0.02. If you didn't know that, you can take 2, divide that by 100, and it'll give you the decimal equivalent of 2%. And also, we're going to leave these 2 boxes blank because we don't know the estimate of our population proportion, and we don't know the population size. That's not going to happen. So those we leave blank, and then click evaluate. And at the very top, you'll see the required sample size, which is in this case, 2,401. So to answer that particular question, if we go back to this slide, the number of golfers that must be surveyed if we want 95% confident that the sample proportion is a margin of error of 2 percentage points, we need to sample or survey 2,401 golfers. Okay, so this is how we use StatDisk to help us solve problems here. Do feel free to email me if you have any questions or concerns about any of the problems that are presented in this video. StatDisk is an easy online software, and it is free of charge. So make sure that you sign up for StatDisk.